So dye solubility test, when emulsion it is mixed with Na, or in the emulsion mix some drops of dye such as scarlet red dye and place this drop of emulsion into the microscopic slide and cover this slide with the cover slip and examine it is under the microscope. If the dispersed globules are red and ground is colorless, then this type of emulsion is
O by W.
O by W.
And if the reverse condition is occur, W by O type of emulsion in which there is dispersed globules appear in colorless and background is
Red. Red color.
red in color. This is about dyes test. The next test is fluorescence test. In this test, oil gives fluorescences in which certain fixed oils possess the physical properties of fluorescences in presence of UV radiation, that is ultraviolet radiation. On the microscopic observation, emulsion under the ultraviolet radiation whole field fluorescences indicate oil is present in the continuous phase, that is W by O type of emulsion, and droplet fluorescences indicate that oil present in the dispense phase, that is O by W type of emulsion. म्हणजे याच्यामध्ये काय करायचं, जे इमल्शन आहे that emulsion observed under the fluorescence test, म्हणजे UV radiations माहिती आहेत, ultraviolet radiations, UV light.
Yes, ma'am.
Yes, ma'am.
त्याच्या थ्रू पास करायचंय. इफ द स्पॉटी पॅटर्न, म्हणजे याच्यामध्ये फेसच्या रिलेटेड सांगितलेलं आहे की इफ देयर इज होल फील्ड फ्लुरोसेन्सेस इंडिकेट ऑइल इज प्रेझेंट इन कंटिन्युअस फेज. जर का ऑइल कंटिन्युअस फेज मध्ये असेल, फ्लुरोसेन्स इंडिकेट काय करतात, अल्ट्राव्हायोलेट रेडिएशन मध्ये ऑइल जर का कंटिन्युअस फेज असेल देन इट इज टाइप ऑफ इमल्शन इज W by O. आणि तसंही W by O मध्ये कंटिन्युअस फेज कोणती आहे,
Oil.
Oil.
ऑइल. जर फ्लुरोसेन्सेसनी असं इंडिकेट केलं की oil it is in a continuous phase, then it is W by O type emulsion. And if droplets is indicated by this fluorescences, that is UV radiation, that oil is dispensed phase. मग oil ही dispensed phase कोणत्या emulsion मध्ये असते,
O by W.
W by O मध्ये असते की O by W मध्ये,
O by
O by
W.
W मध्ये, कारण O by W मध्ये water continuous phase आहे, right?
Yes.
हा. सो ऑइल जर का डिस्पेन्स फेज आहे असं त्या फ्लुरोसेन्सनी इंडिकेट केलं, दॅट इज UV रेडिएशन मुळे इंडिकेट झालं, ऍट दॅट टाइम दॅट इज दिस टाइप ऑफ इमल्शन इज O by W type of emulsion. So this is about fluorescences test, in which fluorescences gives idea about dispense and continuous phase. If continuous phase is oil, then it is W by O type emulsion. If dispensed phase is oil, then it is W by O by W type of emulsion. The next point, test समजले.
Yes.
The next and last point in this chapter is storage of emulsion. हा कसं स्टोअर केलेलं तुम्ही, what is labeling conditions, प्रिपेअर केलं इमल्शन, राईट, का फक्त प्रिपेअर करून ठेवलेलं, लेबलिंग सबमिटेड केलेलं की नाही, yes or no?
Yes, madam.
So depending upon use of emulsion, it should be packed in suitable container. केलेलं का suitable container मध्ये ते pack?
Yes, ma'am. Well,
वर केलेलं का emulsion? So container used for the emulsion storage, in which depending upon the use of emulsion, should be packed in suitable container. For oral use, usually it is packed in well-filled bottles having the airtight closure. Closure जे आहे त्याचे लीड ते एअरटाईट असावं, अशा क्लोजर्स मध्ये ओरल यूज साठी असलेले इमल्शन स्टोअर करायचे. देन लाईट सेन्सिटिव्ह प्रोडक्ट, इफ there is light sensitive products are added in the emulsion, then it should be packed in amber colored bottle. Amber color bottles माहिती है?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Then next point, labeling instructions are given on the emulsion. So in which external use only, for external use only. If the external use product, then clearly mention on their label is they are used externally. And the for external use only by using the red pen. Red pen ni instruction लिहिलेलं का? Label वरती.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Then the label on the emulsion should be mention this product have to be shaken thoroughly before use. Means shake well before use. These instructions should be written in your label. Then storage condition. So it should be stored in airtight container protected from the light, high temperature or freezing, and the emulsion should be required to store into the cool place. So this is about storage condition of emulsion. Emulsion should be stored in airtight container. Means air त्याच्यामध्ये enter होऊ नये असं tight container असावं. Protected from light, sunrays किंवा other ज्या lights आहेत त्याच्यापासून protect व्हावं असं store करायचं आहे. Also sometimes it should be stored in fridge or at the high temperature, and at the end the emulsions are required to be stored in the cool place. So in this chapter, liquid dosage form, in which we discuss biphasic liquid dosage form, emulsion. Okay, this is amber colored container. So in this chapter, firstly we discuss emulsion, definition of emulsion. Emulsion is a biphasic liquid dosage form in which two immiscible phases make miscible by using emulsifying agent, and this emulsifying agent helps to reduce interfacial tension in between these two immiscible phases and make the emulsion stable. This is known as emulsion. So in this chapter we cover disadvantage, types, identification test, method of preparations, HLB scale. All these points are important in this chapter, and also difference. Here we complete this chapter. Liquid dosage form, in which emulsion it is completed in today's lecture. Any doubt?
No, ma'am.
We are going to start next chapter in unit 5. In the liquid dosage form is suspension. So in the suspension are the biphasic liquid dosage form of the medicament, and which are finely divided solid particles. They are ranging from the 0.5 to 5 micron, and they are dispersed in the form of they are dispersed into the liquid or in the semi-solid vehicle. Means there is vehicle is used either it is liquid or it is semi-solid, and in which the solid particles they are finely divided in this very small range 0.5 to 5 micron, and they are dispersed into this vehicle. So that's why it is in a biphasic liquid dosage form. So in this chapter we have to study what is qualities of the good suspension, classification of suspension means the types of suspension, then what is mean by flocculated suspension and deflocculated suspension or non-flocculated suspension. There is difference in between flocculated suspension and non-flocculated suspension. Then after that we will study about formulation of suspension, in which different types of additives used in formulation of suspension such as flocculating agent, thickening agent, preservative, some wetting agent, or some organoleptic additives are added in the formulations of suspension or during the preparation of suspension. After that we will discuss methods of dispensing or preparation of suspension, means by which method suspensions are prepared. The next point in this chapter we have to study is stability of suspension. And last point in this chapter, we have to study evaluation of stability of suspension by using the different methods such as rheological methods, micromeritic method, electrokinetic methods, and sedimentation method. So let us discuss or start from the definition of suspension. Screen is visible to all.
Yes, ma'am.
Yes.
Ma'am.
So suspension, it is in a biphasic liquid dosage form in which medicaments are finely divided solid particles, fine, F-I-N-E, coarse, fine, moderately fine. This type of powder we are discussed in site separation. So in which very finely divided solid particles, their range will be 0.5 to 5 micron. It is dispersed into the liquid vehicle or semi-solid vehicle. It is known as biphasic liquid dosage form, that is suspension. So solid particles in this suspension is act as dispersed phase while liquid particles act as a continuous phase. Means you have idea, you got idea from the emulsion which phase is dispersed phase and which phase is continuous phase. So in this solids are dispersed in the liquid medium. That's why continuous phase is liquid and dispersed phase is solid. So particle size of dispersed phase is very important in the formulation of emulsion. If there is increase in particle size, then it does not give the proper or clear suspension. Suspension, it is an heterogeneous. Heterogeneous means different. Homo means same. Why it is heterogeneous? Why it is heterogeneous biphasic dosage, liquid dosage form? Hetero means different, right? Yes or no?
Yes, ma'am.
Then why it is heterogeneous?
Two phases with solid and liquid.
Okay, very good.
Suspension is a type of solid or liquid phase.
Phases. In which solid, hetero means different phases. One is solid and another one is liquid. That's why it is heterogeneous. So definition of suspension, we can say it is a biphasic liquid dosage form in which medicaments are finely divided solid particles. They are ranging from 0.5 to 5 micron and they are dispersed into the liquid is known as suspension. In which range of the particle, coarse particle and colloidal. So coarse suspension, there is range of dispersed phase is 1 to 100 micrometer, and for colloidal suspension range is
0.5.
1 nanometer to 0.5 micrometer. So these ranges are used for MCQ. If suspension are the heterogeneous biphasic liquid dosage form in which insoluble solid particles are uniformly distributed into the liquid phase and which may be stabilized by inclusion of suspending agent. Means जसं इमल्शन मध्ये इमल्सिफाइंग एजंट ऍड केले जात होते ज्या दोन इमिसिबल फेज आहेत त्या मिसिबल करण्यासाठी लाईक दॅट जे सॉलिड पार्टिकल्स आहेत जे सोल्युबल होत नाही युनिफॉर्मली डिस्ट्रीब्यूट होत नाहीत लिक्विड फेज मध्ये त्याच्यासाठी जे एजंट्स ऍड केले जातात इन्क्लुजन मीन्स ऍडिशन ऑफ using some agent. This agent is known as suspending agent. So these agents are added in suspension. So suspending agent added in which liquid dosage form?
Suspension.
Suspending agent are added in which type of liquid dosage form?
But
Which? एकालाही समजलं नाही की सस्पेंडिंग एजंट कशामध्ये ऍड करायचे
biphasic.
in the biphasic liquid dosage form. Which liquid dosage form? Biphasic मध्ये किती dosage form आहेत?
2 doses.
Two dosage form.
In which dosage form?
Solid. solid,
Solid or liquid.
फर्स्ट इयर लक्ष आहे सगळ्यांचं.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
मग काय सांगताय तुम्ही? सस्पेंडिंग एजंट कोणत्या लिक्विड डोसेज फॉर्म मध्ये ऍड करायचे? सिंपल क्वेश्चन आहे. कोणत्या फॉर्म्युलेशन मध्ये ऍड केले जातील सस्पेंडिंग
Liquid
एजंट?
dosage form of suspension.
सस्पेन्शन कधी सांगणार आहे? लिक्विड डोसेज फॉर्म मध्ये सोल्युशन, सिरप, एलिक्झर हे येतं. सस्पेंडिंग एजंट आपण कधी बघितलंय? फर्स्टली यू लिसन दिस वर्ड फ्रॉम सस्पेन्शन चॅप्टर. काही इमल्शन मध्ये सस्पेंडिंग एजंट ऍड करायचे.
No, ma'am.
No, ma'am.
Which agents added in the emulsion?
emulsifying agent,
Emulsifying agent.
Emulsifying agent.
कन्फर्म माहिती आहे इमल्शन मध्ये इमल्सिफाईंग एजंट बघितलेत आपण. मग ते कॉन्फिडेंटली सांगा ना. सस्पेन्शन मध्ये ऍड करायचे इमल्सिफाईंग एजंट.
No, ma'am.
no ma'am,
So these are the solid particles. Their range is given in their definition. We have to write at such definition. Solid particles are ranging from the 0.5 to 5 micron. मग हे लिक्विड मध्ये असे डिस्पर्स होतात. डिस्पर्स्ड फेज जे इन्सोल्युबल पार्टिकल आहेत ते, आणि डिस्पर्शन मीडियम म्हणजे कंटिन्युअस फेज काय असणार आहे? लिक्विड की सॉलिड?
Liquid.
liquid and dispersed solid,
Okay, so suspension, it is in a two-phasic, that is biphasic liquid dosage form, which consisting of finely divided solid particles, and they are dispersed into the liquid, and this solid particle range is ranging from 0.5 to 5 micron. This is known as suspension. समजले definition suspension ची?
Yes, ma'am.
yes ma'am,
Yes, ma'am.
And if there is insoluble particle, मग आपल्याला suspension म्हणजे कसं बनवायचंय? हे असं. Is it visible in your screen?
Yes, ma'am.
मग असं बनवायचं आहे. याच्यामधून लाईक दिस हे असे सॉलिडचे पार्टिकल्स येतील तर चालेल का? ते प्रॉपर इमल्शन असेल का?
No.
no
No,
ma'am,
ma'am.
We have to make like this. That's why जे इनसोल्युबल पार्टिकल्स आहेत याच्यामध्ये, तर त्या पार्टिकल्सला त्या लिक्विड फेज मध्ये सोल्युबल करण्यासाठी जे एजंट्स यूज केले जातात, that agents used as a aid in this combination is known as suspending agent, and that's why at such liquid dosage form मध्ये दिसत नाहीत. This makes soluble and we get such type of preparation. Do you understand what is mean by suspension and what is role of suspending agent in the suspension?
Yes,
समजले?
ma'am.
The next, properties of suspension. Good qualities of suspension. A formulated suspension should have following properties: easy and rapid redispersion of sedimented particles for uniformity of dose. म्हणजे sedimentation particles suppose खाली जात असतील, by proper mixing, stirring or shaking, it is easily available. So easy and rapid redispersion. जरी particles at the bottom sediment झाले असतील तरी ते by shaking properly येतात. That's why it is one of the advantage of suspension. No cake formation on the sedimentation. म्हणजे sedimentation at the bottom ला झालं तर केक फॉर्म होत नाही. ऑप्टिमम केक फॉर्म का होत नाही? कारण आपण त्या बॉटलला शेकिंग केलं तर ते जे बॉटमला सॅच्युरेट झाले ते काय होणार आहे? रिडिस्पर्स होणार आहे. पॉसिबल आहे का रिडिस्पर्स होणं सस्पेन्शनचा? येस सर नो? रिडिस्पर्शन म्हणजे जे पार्टिकल सगळे बॉटमला जातील. साऊंड इज ऑडिबल टू ऑल?
yes ma'am,
Yes, ma'am.
मग ते पार्टिकल ज्यावेळेस बॉटमला सेटल डाऊन झाले ते ऍज सच रिडिस्पर्स होणं पॉसिबल आहे का?
no,
काय वाटतं तुम्हाला? व्हॉट डू यू थिंक? ही बॉटल आहे, याच्यामध्ये सस्पेन्शन आहे, असं स्टेबल आहे, तर त्याच्यामध्ये जे पार्टिकल्स बॉटमला गेलेत, इन केस देर आर फाईन पार्टिकल्स इन देअर रेंज 0.5 to 5 मायक्रॉन, तर ते नंतर रिडिस्पर्स होतील का? येस ऑर नो?
No.
No, ma'am.
No.
मिक्स केल्यावर रिडिस्पर्स म्हणजे काय? जर आपण ती बॉटल शेकिंग केली, मिक्सिंग केलं, तर ते रिडिस्पर्स ऑफकोर्स होणार की जरी आपण मिक्सिंग हलवतोय ती बॉटल तरी ते बॉटमला राहणार आहेत का?
नाही.
No.
No, ma'am.
मग नो कसं म्हणता रिडिस्पर्स होणार नाही? रिडिस्पर्स होणार. म्हणजे जरी पार्टिकल बॉटमला गेले, आपण बॉटलला मिक्सिंग केलं, शेकिंग केलं, ऍट दॅट टाइम ते पार्टिकल्स मिक्स होणार आहेत. होल लिक्विड जे आहे त्याची जी व्हॉल्यूम आहे त्याच्यामध्ये मिक्स होणार आहे. दॅट्स वाय देयर इज नो केक फॉर्मेशन. मग तुम्ही नो म्हणताय, रिडिस्पर्स होत नाहीत, तर मग केक फॉर्मेशन होईल. मग तसे फॉर्म्युलेशन असतात का सस्पेन्शनचे? बघितलं का
हो.
बॉटल मध्ये केक फॉर्मेशन झालेलं?
नसते तशी.
नाही. असते.
Okay, that's why there is redispersion form in the suspension. Then physical and chemical stability is maintained at optimum viscosity. जे viscous nature आहे, use केलंय suspension.
Yes, ma'am.
Administration. Okay, so त्याची viscosity जी आहे ती viscosity, optimum viscosity of for pouring is maintained and free grating particles in case of external use. म्हणजे ग्रेटिंग पार्टिकलची जी रेंज आहे ती बायफेजिक लिक्विड डोसेज फॉर्म मध्ये मेंटेन करता येते. सो दीज आर दी प्रॉपर्टीज ऑफ सस्पेन्शन. अँड ऑल्सो सस्पेन्शन कसं असायला पाहिजे? केमिकली इनर्ट असायला पाहिजे. देन सस्पेंडेड पार्टिकल म्हणजे हे जे पार्टिकल्स आहेत, फाईन पार्टिकल असतात, त्यांनी केक फॉर्मेशन. देर इज सस्पेंडेड पार्टिकल्स और डिस्पर्स्ड पार्टिकल should not form a cake. Cake form नाही व्हायला पाहिजे. Then सस्पेन्शन इझिली कंटेनर मध्ये पुअर करता यावं अशी त्याची विस्कोसिटी असावी. अँड ऑल्सो ते इझिली रिडिस्पर्स व्हावं. बाय दिस वे ते प्रिपेअर करायचं आहे. सो दीज आर दी आयडियल प्रॉपर्टीज ऑफ सस्पेन्शन. The next point in the suspension is types, different types of suspension, that is classification, in which based on their general classes, oral suspension, externally applied suspension, parental suspension, ophthalmic suspension, based on the proportion of solid particles, dilute suspension, concentrated suspension, based on electrokinetic nature of solid particles, flocculated suspension and deflocculated suspension, based on size of solid particle, colloidal suspension, coarse suspension and nano suspension. In colloidal suspension, their solid particle range less than 1 micron, in coarse greater than 1 micron, and in nano suspension 10 nanogram. Then in based on proportion of solid particle range in dilute suspension 2 to 10% weight by volume solids, and concentrated suspension 50% weight by volume of solid. So in this type of suspension, we have to study in detail about what is mean by oral suspension, their advantages, disadvantages, what is mean by parental suspension, ophthalmic suspension, and suspension for external use, and what is mean by deflocculated suspension, flocculated suspension, their difference we have to study in the detail. Type समजले?
Yes, ma'am.
Yes, ma'am.
The remaining types or their explanation we will discuss in our next lecture. Up to this, their classification, ideal qualities, and definition, and what is meant by suspending agent, and these ranges. About this, any doubt?